I would like to look at gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute. And you're going to tell me what this represents in a minute. It forms a pile of a cone and the cone has always the diameter and the height are always equal. Diameter and the height. Here is the diameter of the cone and here's the height of the cone. At any point in time, they are equal. Question, how fast is the height? How fast is the height of the pile increasing when the pile is 10 feet high? I want to come back to the first problem just for one moment. Notice that this piece, the 2-hour thing, is used only at the end. Used only at the end. Do not consider this information part of the problem till you're absolutely done with finding the rate of change as a relationship, and then you plug in the numbers. However, this is fixed. This is carved in stone. I have to take this into account from the very beginning because it stays all the time. We pile the sand in that spot. So the diameter and the height are always the same, no matter what, at any point in time, beginning, the end. But this is used 2 hours only at the very end. So be very careful with that. Every time the problem says, how fast, blah, 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 when, anything that follows after the word when has to be used at the very end. When you established the function, you differentiated it, and now you're plugging in numbers. So you can disregard all this. After it says when, forget it, till the very last step. Okay, so first of all, we have to establish what this is. If we don't know what this is, we can't start the problem. Not too difficult, because I see the measurement unit is cubic feet, and I see the measurement unit, which is minutes. So I know what this is. Can anyone give it a shot? Thank you very much. The rate of change of volume with respect to time. Excellent. So now that we have to look at the volume of a cone. 4 pi over 3 r squared h. That's a sphere with 4 pi. So it's pi over 3. Pi r squared h is 1/3. This is how we should remember it always. 1/3 of the volume of a cone. I meant cylinder. So a cylinder, that's how I remember those. So this is the height and this is the radius. So it's the area of the base, pi r squared times the height. And this is 1/3 of it. So the volume of the cylinder is the area of the base times the height. So pi r squared multiplied by h, volume of a cylinder, and the cone is 1/3 of it. 4 pi over 3 r cubed is the volume of a sphere. Say it again.
What's the word? It's 1/3 d what? I'm sorry.
Cylinder. Cylinder. Sorry about that.
Okay.
Cylinder. So it's 1/3 of the volume of a cylinder. When it dries out, I'll write it again, or I can write it again about. So cylinder. Okay, perfect. So I have the volume. I'll write it here one more time. Now I have to ask myself, what am I asked to determine? That's the next key. How fast is the height changing? So what is this? What is the question? When the height... Say it again. I'm sorry, I talked at the same time.
Is it dH dt?
dH divided by dt. Awesome. Thank you very much. Great job. So how fast is the height? How fast is the height changing? When? Blah, blah, blah. I don't need to know right now, but this is our question. Perfect. Now, from the very beginning, I have to note that the height is the same with two radii at any point in time. Since I'm asked to find the height, I want to somehow remove the radius. Not a problem. I'll divide both sides by 2 and say the radius is the height divided by 2. And this is what I'm going to do. Replace the radius by the height over 2. Because I don't have any information about the radius. Anyway, in the sense that I'm given the information, so it's the best thing to right away replace it because that's fixed in the problem. So V equals pi over 3 radius h over 2 everything squared and multiplied by the height. This is our volume. It's a function of time. The height is a function of time. So here we have two functions of time. Simplify. Pi over 3 h squared over 4 multiplied by h. Simplify again from here. Volume equals pi over 12 h to the third. This is the equation we need. And from here we will differentiate implicitly to determine dh over dt. The two functions of time are v and h. So when I differentiate implicitly, the left-hand side is dv over dt. The right-hand side is pi over 12 multiplied by 3 multiplied by the height squared and multiplied by dh over dt. I will simplify. What do I simplify by? I'll simplify the 3 and I get a 4 here. And I am going to solve for the variable of interest. I will multiply both sides by 4 and divide both sides by pi h squared. So then dh over dt becomes 4 divided by pi h squared multiplied by dv over dt. I want you to understand that this is compact, right? This is one variable. This is the derivative of the volume. You cannot separate the dv from dt. So I multiply both sides by 4 and I divide it by pi h squared. At this point, problem is done. I am ready to plug in 10 for height, and dv over dt was given to us from the very beginning as 30 cubic feet per minute. So I can continue. 4 divided by pi multiplied by 100 and multiplied by 30 up here. I can simplify by 10, top and bottom. I can simplify by 2. So the numerator is 6 and the denominator is 5 pi. I cannot simplify any further. I will approximate, but because this means nothing, I don't know what 6 over 5 pi is. Be careful to put in parentheses 5 pi, or divide 6 by 5 and further divide by pi. So 6 divided by parentheses, 5 multiplied by pi, and close the parenthesis, and I got 0.382. Without a measurement unit, it means nothing. And what is the measurement unit? Thank you very much. Great job. Okay. Any questions on this problem? Can we select another?
Yeah, when I plug in 6 over 5 pi, I get 3.77.
If you did not put parentheses around 5 pi, you're not getting the correct answer.
Okay.
I said that. So if you don't want to put parentheses around 5 pi, then you can do it like this. 6 divided by 5 divided by pi. If you don't want to put parentheses,
Okay.
and you have to get the same answer.
Thank you.
But if you don't put parentheses around 5 pi, you are dividing 6 by 5 and you are multiplying by pi. The answer of 6 over 5. Careful, because this calculator is not as sophisticated as you are. You know more than the calculator. Perfect. Perfect question. Thank you so much. Okay, here's the next problem. We have a kite 100 feet above the ground. So here's the kite somewhere. It is 100 feet above ground and moves horizontally this way, or that way, doesn't matter, at a speed of 8 feet per second. Okay, so there is a person right here with a string. Here's the kite, and here's the person at the ground level, moves horizontally at a speed of 8 feet per second. At what rate is the angle? Theta. At what rate is the angle between the string and the horizontal decreasing? When I hear or read the word decreasing, I expect a negative rate of change. Although tiny, it's still positive. It's increasing. Once I hear the word decreasing, I make myself a note. If you don't get a negative rate of change, go back to the drawing board. Something is wrong. So when the horizontal, okay. So find the, okay, I'm going to write the question. At what rate is theta decreasing? When, and you know that I don't care about the when, but I would write it. 200 feet of string has been let out. So remember this later, much later. We need to make sure that you're not putting into any calculation at this point. So let's read the problem one more time. A kite is 100 feet above ground and moves horizontally at a speed of 8 feet per second. At what rate is the angle between the string and the horizontal? decreasing when blah 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 of string has been let out. So first we have to establish what we are given.